We have example 7. Solve the equation log to the base 2 of the expression x minus 1 plus log to the base 2 of the expression x minus 3, and that's equal to 3. So first, of course, we're going to deal with the logarithms, and we have to be very careful with the properties. We have to what do you call this? We always have to think about the properties. And indeed, we could find something that would reflect the property of the logarithm for the products. So we've got here, as you can see, we've got an operation of plus. So it's an addition. Therefore, the property that could be used is of the product of the two expressions or two factors. So we have a base 2, and the expressions are x minus 1 and x minus 3. So taking into argument the property of the logarithm of the product, which is equal to the logarithm of each of the individual factors, the sum of the logarithm of the individual factors. So this one is equal to 3. And after that, we will have to make use of the definition of the basic logarithm expression itself, which is log b x is equal to y. And this is, as I've said before, interchangeably taken or expressed into b raised to y is equal to x. So let us apply this form on this expression. Our base is 2, so that gives us 2 as a base, and our exponent is 3. So of course we will have 2 raised to 3, and that gives us the argument, which is x minus 1 times x minus 3. So 2 raised to 3 is numerically equal to 8. And for this case here, we need to use the FOIL method in order to expand the entire expression. So this gives us, first expression would be x squared minus 3x minus 1x or x plus 3 using the FOIL method. So we use the FOIL method in here. Okay, now if you are algebraically advanced, you could just use mental computation or mental evaluation for the expansion of this expression here. So therefore, as we continue, 8 now is equal to x squared minus 4x plus 3, and that gives us, we need to rearrange the equation. So I would take the expression from the right taken to the left or transformed to the left. So x squared minus 4x plus 3 is now equal to 8, and that gives me x squared minus 4x plus 3, and we transform 8 to the left also. So that gives us minus 8 is equal to 0. And this gives me x squared minus 4x minus 5 is equal to 0. Now this expression is factorable. Okay? So we could solve it by factoring. There's another method, which is the use of quadratic formula. If you want to use the quadratic formula, x is equal to negative b plus or minus b squared minus 4ac all over 2a, given the quadratic form or expression ax squared plus bx plus c. So if you want to use the quadratic formula, you must be able to identify which is a, which is b, and which is c. In this case, our a is equal to 1, because this is the leading coefficient or the coefficient of our x squared, and our b is equal to -4, and C is equal to -5. Okay, and then substitute these values of A, B, and C to the equation here, to the expression here, to solve for your x's. Okay, but in this case, I'm going to use the factoring method to solve for my x. So when this expression here is factored, I would get, we have xx and we have factors of -5 that when added together will give us a sum of -4, which is the middle expression. So we have x minus 5 and x plus 1. And therefore my x would be equal to 5, and another one is -1, setting both equations into 0. So by setting both equations into 0, x minus 5 is equal to 0, giving me x is equal to 5 for this case. And for this case, I have x plus 1 is equal to 0, x is equal to -1. Therefore, giving me this solution set for x. But we are not finished with that. We need to check if the given values of x are true for the logarithmic equation given in here. So is it true? Are the values of x that we got true for this expression here? Now let us check. So our given solution set for x on this expression is x equals 5 and -1. So x is equal to 5, and on the other side we have x is equal to -1. Now let us perform an individual evaluation of the values x equals 5 and -1 to check whether these two values fit for the original equation that is present here. So let us take x is equal to 5, for example. So this gives me log of the base 5 to the argument of x minus 1. Then we substitute x equals 5 for x, and that's log 5 of 5 minus 1 plus log 2 of 5 minus 3. Is it equal to, I need to move this a little bit. Okay, so is that equal to 3? Okay, now let us check. This becomes log 5, and the argument is 4 now, plus log. Okay, I've got the wrong base for the first expression. It should be 2. Okay, am I blind or something? Okay, so this is 2. All right. Okay, so this is log 2, and this is log 2. Okay, so now this gives me log 2 to the argument 2. And is this equal to 3? This is still a question. Now this expression here, they have individual values. For example, in this case, let us say let y is equal to, or let us not use y, because we might be confused when we take y as a function itself and y is a variable. So let us use u as log 2, 4. So the value of this log 2, 4 is u, and taking the exponential form of this part here, we will get 2 raised to u is equal to 4. And if I want to get my u, then I have to raise the right expression or the right value into the same base with the left expression. So they now have the same base, therefore my u is just equal to the exponent here. So my u here is 2. On the other side, then let us have v, let v is equal to log of 2, 2. So I have 2 raised to v for the exponential form of this one is equal to 2. And 2 raised to v is equal to 2 raised to 1. So our v here is just equal to 1. Okay, but you can use the log function in your calculator. Okay, we have a log function in there wherein you just have to put the values of your base and the arguments, and you will get the value. So in this case, I'm using algebra, okay? But this is not always, what do you call this, practical, especially when you are to compute the value in checking without wasting your time. But in this case, I just use the algebraic method. Okay, so we have 2 now. So going back to the original expression. So this value here is 2 plus 1. Now is it equal to 3? Yes, they are. So therefore, the value of your x is equal to 5 is acceptable, and it is indeed in the solution set of the equation log to the base 2x minus 1 plus log 2x minus 3 is equal to 3. Now how about this? Okay, what about this expression? So let us use again, okay, the values, substitute the values for x's. So we have -1 minus 1 plus log of 2 -1 minus 3 is equal to 3. So you could see that we get some form of negative numbers. So log 2 of -2 plus log 2 of -4. Is it equal to 3? So that's the question. Are the values on the left equal to the values on the right, or to the value on the right? Now let's take your calculator, okay? In this case, we're going to use your calculator. You could see that there's a log function in there with some of the blanks left for the values to be encoded. So let us use our base 2 for the blank below and -2 for the argument. So that gives you an error. So it's an error, okay? And here also is an error. Therefore, we could not use, or we could not get a log of a negative value. So in this case, our log of the -2 is undefined. Therefore, this expression is undefined. And is it equal to 3? Certainly not. So you could not use x equals to -1 as your solution set for the expression log 2x minus 1 plus log 2x minus 3 is equal to 3. But we could use this one as the solution set. So this is the answer.